In this video, we're going to look at our rational exponents and radical expressions. What we're going to do is convert between our radicals, like we were talking about yesterday, and write them in a new way using rational exponents. Now remember, rational just means can be written as a fraction of integers, so we're going to talk about writing our exponents using fractions. I want to point out this is just a change in the way that we're writing our radicals. It's not actually a new process. It does allow us to do a certain number of things, like simplifying our radicals using our exponent rules. That's why we do this. Now we're going to go very basic here. My radical typically is going to have an index and an exponent. Now I wouldn't use I and E normally because those both mean something else in math later on down the line, but I want to make it very clear that when I rewrite, what's going to happen is my exponent is going to go in the numerator, my index is going to go in the denominator, and then that whole fraction is going to be in the exponent position. So let's take a look at just doing some converting between radical notation and rational, and then converting between rational and radical. So we're going to start over here. These are in radical notation, so I've got the radical sign there. Remember, this one would be said the fifth root of t. So t is my base, so when I rewrite it, t is going to stay my base. I've got an understood exponent of 1, and I've got an index of 5. So my exponent here is going to be 1/5. You're going to have to write pretty small. I didn't leave you a whole lot of room, so just do the best you can there. All right, number 2, we would say this as the square root of g. Remember, when there's no index on our radical, it's understood to be a 2. Our base is g. Once again, our exponent is understood to be 1, and our index is 2. So it's g to the 1/2. Now number 3 gets more complicated. I've got the cubed root of 4x squared y to the 7th. When I rewrite this, I'm going to take each base individually and write it with your rational exponent. So I'm going to start with the 4. It has an exponent of 1 and now an index of 3, so 4 to the 1/3. Then I'm going to do the x. It has an exponent of 2 and an index of 3. And then I'm going to do the y. It has an exponent of 7 and an index of 3. So overall, that's my 4 to the 1/3, x to the 2/3, and y to the 7/3. Example 4. So this is the 4th root of 2 to the 5th. 2 is my base. And then for my exponent, 5 is my exponent, 4 is my root. So 5/4. And then in number 5, we would say this as the 3rd root of 10x to the 6th to the 4th. Now I'm going to kind of take this in 2 steps. I'm going to do the 3rd root first, and then I'm going to do the to the 4th part. So I'm going to look at each base. So I'm going to do 10. It has an exponent of 1 and a root of 3. X, it has an exponent of 6 and a root of 3. And then I've got to keep that 4th. So all I've done in that step is 10 to the 1/3, x to the 6/3. Now before I take care of that 4th, I'm actually going to simplify that. That 6/3 I can rewrite as 2. So it's 10 to the 1/3 x squared to the 4th. And then I can use my exponent rules. I need to do power of a product and power of a power. So 10 to the 1/3 to the 4th is 10 to the 4/3. and then x squared to the fourth is x to the eighth. We're going to talk about using those rules a little bit more later. So again, because I know that's a little hard to see, 10 to the 4 over 3, x to the eighth. The eighth's coming from 2 times 4. Okay, now we're going to go the other direction. So we're going to start in rational exponent notation, and we're going to convert over to radical. So here, m to the 1/6. So m is my base. I'm going to keep my m. I'm going to draw in my radical. 1 is my exponent. 6 is my index. I don't really need the 1, but I'm going to leave it there just for the sake of this video. Okay, here. The 3 doesn't have an exponent, so the 3 is not part of a radical. The n is the base of the radical. It has an exponent of 2 and a root of 5. So that's 3, and then the fifth root of n squared. Okay, here my base is 2. Making my radical, I have an exponent of 5 and a root of 3. So the cubed root of 2 to the 5th. Number 9, the 10 does not have an exponent, so it's on the outside. The x is my base, an exponent of 3, a root of 2. I don't need to write that 2 there. I can leave it off because when there's nothing, it's understood to be a square root. Okay, before I can rewrite this one, I'm actually going to go ahead and take care of that negative, because I don't have a way to write the negative using my radical. So remember, the negative exponent just drops you to the denominator and makes it positive. So that's going to be 1 over, my base is 5x, my exponent on both is 1, my root is 2. So it's going to be 1 over the square root of 5x. And that is it for our rational exponent notation.